Alright, welcome once again to our G channel. Today we are going to look at how to simplify geometric progression. So without wasting time, geometric progression is a set of numbers in order being multiplied by a fixed constant. So the next number in line is being multiplied by a fixed constant to obtain the subsequent numbers. So let me repeat. I said geometric progression is a set of numbers in order. So each number is being multiplied by a fixed number called the common ratio. So for example, if the first number is 2, so to obtain the next number, you need to multiply by a constant ratio, let's say 2, to give you 4. You also need to multiply again to another constant ratio, which is 2, to give you what? 8. You also need to multiply by another constant ratio, or a fixed number, to give you what? 16. So this is what we call geometric progression. We say it's a set of numbers in order being multiplied by a constant or a fixed number to obtain the subsequent numbers or the next number. So that is what geometric progression is all about, right? So now quickly let's look at how do you find the nth term or the number of terms of geometric progressions. So the nth term of a geometric progression, the nth term, Tn, of a geometric progression. So the nth term of a geometric progression is given as what? Tn is equal to ar raised to the power n minus 1. So with this particular formula, you can be able to tell what the next 100 term will be, right? So to find the next 100 term, so let's assume, okay, let's go back to that our first sequence, which is 2 followed by 4 followed by 8 followed by 16 followed by 32. So let's stop here. Now you can encounter some challenge where they will ask you to find what is the 20th term. So this can be your first term, this one will not be your second term, this one is your third term, this one is your fourth term, this one is your fifth term. So following this pattern, now some question you may encounter a problem where you are asked to find the 100th term. The 100th term, T100. So what do? This formula, that is where this formula comes in. So this formula helps you to get the subsequent terms without following this particular order. So that is the essence of introducing the nth term. It enables you to see the next 1000 term without actually going through this process, right? Okay, so let's go back to the nth term. So we start with the nth term is equal to ar raised to the power n minus 1. So let's define all the terms that we have here. So Tn we have defined that we say is the nth term. N stands for number of terms. Right? A represents the first term. R is what we call the common ratio. So this is the fixed number or constants that you use to obtain other terms or the next number. So this is the common ratio. So N represents number of terms, A represents the first term, R represents the common ratio. Now, how do we find the common ratio? So to find the common ratio R, we can say the second term divided by the first term, or you can use the third term divided by the second term, or you can use, they are even equal, there's no need of saying or. And this is the same thing as using the fourth term divided by what? The third term. So with this you can obtain your what? Common ratio, right? Okay, so That's all we need to know for now. So we are going to look at our first example. So let's just run through it again. We said that how to find the nth term is this, the formula a r raised to the power n minus 1, n represent number of terms, a first term, r common ratio. And we can say that you can divide the first term, the second term by the first term, or the third term by the second term, or the fourth term divided by what? The third term. Okay, let's go to our next example, or example 1 under geometric progression. Okay, before we go into the first example, let's quickly look at how to generate the terms from the formula, right? So let's look at the first term. The first term T1, which is equal to A. Okay, now it means that from the first term, we are trying to generate the first term, second term, third term from the nth term, right? So first term means wherever you see n, put 1. Okay, let's look at the nth term again. So the Tn is equal to Arn minus 1, right? This is the nth term, right? The general term. So now first term T1 is equal to, now I want you to understand this. We have removed the n and replaced it with what? 1 to obtain the first term, right? So all we need to do is wherever we see n, we are going to replace it with what? 1. So if we do that, we have ar1 minus 1. So this will give us what? ar raised to the power 0, which is what? A. So that is how to obtain the first term. Now the second term T2 means wherever you see n from the nth term, replace it with what? 2. So if we do that, we have ar2 minus 1. So this will give us what? Ar raised to the power 1. You see it. So what about the third term? The third term T3 is equal to ar3 minus 1, which is equal to ar squared. Please, you need to master this because everything around geometric progression revolves around your ability to interpret this. It's very, very important how to generate this from the formula. So the fourth term T4 is equal to ar4 minus 1, which is equal to ar raised to the power what? 3. Now if you are to follow this pattern, just study it. T1a, T2 ar raised to the power 1, T3 ar raised to the power 2, T4 ar raised to the power 3. So if you are to follow this particular pattern, you discover that, let's say T10, 10th term, T10 will definitely give us what? AR. I want you to guess before I write the answer. I know you got it. AR raised to the power what? 9. So if you are to follow this particular pattern, you arrive at T10 is equal to AR raised to the power what? 9, right? So that is how to generate it. So please, you need to understand this so that in case if they ask you to find the 25th term without even solving the problem, you can easily say that T25 or 25th term T25 is equal to AR raised to the power what? 24. AR raised to the power 24. So if they say T50 or the 50th term or T50 can easily give you AR raised to the power what? Guess 49, right? So it's just n minus what? 1. So you need to understand how to generate this. Okay? Alright, so let's go back now and look at our example 1, having been able to interpret and explain this. Okay? Okay, now we are going to look at our first example for today. They said that if a sequence has its terms as 16, 32, 64. They say find the first one, its first 12th term and its what? nth term. Now, the first thing, there are some problems that when you look at them like this, you don't know whether it is an arithmetic progression problem or a geometric progression problem, right? Now, if you look at this problem, now if you're not careful, you think that it's an arithmetic progression problem. Can you see it now? If you look at it, it looks like an AP problem. So the only way you can differentiate whether it is an AP problem or a GP problem is to look at the sequence. What is the difference? What is the difference between this number and this one and this one? Now, if you discover that the difference between one number and the other has to do with multiples of a constant, like if you multiply this by 2, you get this. Multiply this by 2, you get this, right? It means that if you multiply this number by 2, you get the next one. So this is the method we use to differentiate whether it is an AP problem or a GP problem. Now, for a GP problem, the difference between this number and this number must be 2. The difference between this number and this number must be 2. Difference means if I add 2 to this, you get the next number. If I add 2 to the next number, you get the next number. But it's not like that here. Here, you have to do multiples of what? 2 to get this next number. So this is a geometric progression problem and not an arithmetic progression problem. So you need to take note of that. So when you look at the sequence, you look at the order. Is it going by multiples of a constant, or is going by just by adding a constant to that particular sequence to obtain the next number? So that is how to differentiate between an AP or a GP problem using the either multiplication or addition. It can be multiplication, it can be division, it can be addition and subtraction. If the difference between one number and the other, if the difference between this number and this number, like if I add 2 to this number, I will not get this. If I subtract 2 here, I will still not get this. So this is not an AP problem. But if I multiply 2 to this number, I will get this. So this is an AP problem. If I divide 2 with this, I will get this. So this is a geometric progression problem. Okay, quickly, let's look at the solution. So solution. So this is our solution. Now Tn is equal to a plus n is equal to ar raised to the power n minus 1. Now, what is our a? So you go back again and look at the first term, the second term, the third term. So we say a is equal to 16. So how do we obtain the common ratio? We divide the second term by the first term. So we have what? T2 divided by T3, or T2 divided by T1, or which is tempting as well, T3 divided by what? T2. Anyone you want to use will give you the same thing. So T2 is 32, T1 is 16. So 32 divided by 16. So let's use this one. 32 divided by 16 will give us what? So we have R is equal to, this into this we have 1, into this we have 2. So our common ratio is what? 2. And our A is what? 16. So we substitute T12, because they said the first question said we should find the 12th term. So T12 is equal to AR raised to the power 12 minus 1. So this is equal to AR raised to the power 11. AR raised to the power what? 11. So if we substitute what we have here, we have what? A is 16. Our first term is what? 16 times R. Our R is what? 2 raised to the power 11. Raised to the power 11. So this will give us what? 16 times 2 raised to the power 11 will give us 2048. 2048. So we look at it again. Say 16 multiplied by 2048. That will give us what? 32768. 32768. So this is our 12th term. So we go to the second one, II. which is equal to, so we should find the nth term. Tn is equal to ar n minus 1. Tn is equal to a, which is 16r is 2 raised to the power n minus what? 1. So this one, we cannot go beyond this. So we have 16 times 2 raised to the power n minus 1. So we can't go beyond this because of the power, right? So this will be our first example for today. So we'll quickly move to the second example. Okay, now this is our example 2. So we're going to look at our second example now. They say that the eighth term of a GP is 640. If the first term is 5, find the common ratio and the what? 10th term. Very simple. So it's a solution. So before you solve any problem on geometric progression or even arithmetic progression, always remember to state your nth term. So we say Tn is equal to ar raised to the power n minus 1. Now we look at what we have here and look for a way to define them. So we look for a way to define this 8th term. 8th term means T8. And T8 is ar raised to the power 7. I hope you still remember how we got it. So you can say Tn is equal to ar n minus 1. T8 is equal to ar 8 minus 1, which is equal to ar raised to the power 7. So that's how we got this one, right? Okay. Now we look for another thing again. They say is 640. So it means that you are going to remove this T8 and replace it with what? 640. So if we do that, we have 640 is equal to ar raised to the power 7. So let's go back to the equation again. They say if the first term is 5, so but a is equal to 5, means wherever you see a here, you put what? 5. So this will be 640 is equal to 5r raised to the power 7. 5r raised to the power what? 7. So if we simplify it further, this will give us I think here we divide both sides by, okay, let me write it up here. So we have 640 is equal to 5r raised to the power what? 7. So we might want to make r raised to the power 7 the solid formula. So we divide both sides by 5. So this will cancel this. We have r raised to the power 7 is equal to what? 128. 128. I hope that is taken. So that will give us 128. So we are going to take the 7th root of both sides. Take the 7th root of both sides. So if we do that, we have the 7th root of this. So the 7th root will cancel the power of 7. So we have r, and 7th root of 128 will give us what? 2. So we have answered the first question that said we have answered this question. So the next one says we should find the 10th term. Let's find the 10th term. 10th term, T10 is equal to ar raised to the power 10 minus 1. So T10 is equal to ar raised to the power 9, right? So this will give us our a is 5, our r is 2 times 2 raised to the power 9, right? Okay, now 2 raised to the power 9 will give us 512. So this will give us 5 times 512. All right. So 5 times 512, T10 will be 5 times 512 will give us 2560. 2560. So that's our 10th 10. So let me write it well. T10 is equal to 2560. Alright, so that will be all for today. Thank you for watching our video. Remember to subscribe to our channel, and also remember to suggest if you have any problem based on this particular topic. Simply type it on our comment section and I will give you a response. If you have any other topic in mathematics that is giving you a bit challenge, just feel free to also comment. We welcome your idea, we welcome your suggestion, we also welcome your criticism if there is any. Thank you and see you soon.